So good morning, everybody. Today I'm going to present you this presentation in French. So I hope you know. Don't work? Okay, great. So I'm going to go with English then. So sorry for my bad English. If you find some words that are quite not good for you, sorry about it. That's not my first language though. So today we're going to speak about the alredo actually with this presentation. So I'm going to go through the history and the evolution of that chemicals and how we go with this and the process to do that chemicals. So first of all, what you should take into account is that the fingerprint found at the crime scene lead to more suspect and generate more evidence in the court than all other forensic technique combined for now. Actually, with the DNA going on, could change in some years from now, but for now, that's what we could take into account. So we see with the treatment on porous surface that we could go with the anhydrine, the DFO, the indandion. You could even go with the magnetic powder if you wish. Actually, the results are not so good, but you could get something. And you got the physical developer, usually. And when you go on wet porous surface, in that case, you got the multimetal deposition and the physical developer. Multimetal deposition is a pretty complicated stuff, and actually it's not really used in North America, more in Europe, but well, that exists, so you must know that at least that could be done. Now, the alredo can be added to that list of chemical that you could use. The advantage that you have with the alredo is that it's a non-destructive technique compared to the physical developer, for example. It's not really time-consuming. The chemicals don't cost a lot, so that's important. It's really simple to apply, actually. That could be used in the field, either than in the lab. You don't need to monitor the development during the process. That is really important because actually when you're in the lab, sometimes you have to do a lot of chemical process at the same time. So if you get to look only to one process, actually you're not losing your time, but well, you're targeting only one thing at a time. So you couldn't do a lot of files in the same time. It doesn't render the paper weak, just like the physical developer do, and the glassware are pretty small compared to the physical developer again. The history. When I was hired by my police department, the first thing they asked me is what could you do for the field? So actually when they show me all the technique and all that stuff, I found that the physical developer was really complicated to do. Actually, you have to get some kind of chemical background or something, or at least practice a lot to know how to do it. So that was really difficult for almost all guys in the office to work with that chemical. So try to find a technique that would be easier for wet porous surface at the beginning for field tests, or even bringing this into the field right on the crime scene and try to do something with it. So I got a big biology background, so I thought, well, what is the better way to find lipid stain or use it? Well, when we do with biology, we go with cell membrane, so that could be interesting. So I tried with the alredo. Actually, all the chemicals they use in biology is not good for us. So all the mixing they do, that just don't work with paper. So I try to work out, to find out what is the best technique to use, try with the chemicals, a way to make a better concentration, to darken the process, to have more reddish purple color. The time that I should use the chemicals to have a good fingerprint stain. So I worked a lot with that kind of stuff, with the buffer and all that stuff. And finally, I got a final recipe in 2004 that I published in the GFI. So since the first recipe, the alredo stain solution itself hasn't changed. What I've changed is the buffer solution. So I managed to make kind of a buffer solution which is more stable than the one we used at the beginning. Finally, in 2008, the Australian make an article in the GFI that confirmed that the actual alredo stain solution contained the perfect concentration of all the components that has been used in it. So that's pretty cool, because actually that's kind of an outside verification, and with another country. So that's pretty important, just for the weather and the temperature, humidity, and all that stuff. So that's important. So the alredo, what is that stuff though? The alredo is a lisochrome, so it's kind of a lipid stain. That's important. In the composition of that lisochrome, you got two nitrogen link, and the alredo is a lipid specific and sensitive to all the lipids actually. So that's pretty important. The alredo by itself is red, when you use the chemical I put into the recipe, it becomes darker, so it helps you to have a better definition for your fingerprint. Water solubility, actually it's insoluble in water and a bit soluble into ethanol. And that's important. You're going to see why later on when I explain the principle of why it stains the lipids. So the Oredo is part of the what they call the Southern family. So we got the Southern Black in this, the Southern 3, the Southern 4, and all the number you want. So actually the Oredo into the Southern is the more red, vivid color that you got. The Southern Black, as you know, is more kind of blue, black, blue colors. So actually, and it don't work pretty well on paper either. So I just give it a try, and that's not pretty cool. Well, I tried almost every kind of biological stuff before finding the Oredo. So actually, you must try before, eh? So in the biology, we use that kind of stain to find lipoprotein. So we could use it into electrophoresis separation, electron microscopy, all that kind of detection into histology. So that's the kind of thing that they are doing in biology. And this is what we got as a result with the fingerprint. Actually, it's using the same stain, but not the same solution. So that's important to know. I don't know if you see well enough in front, yeah? So here we got the molecule. So you got the nitrogen bond that I was talking about. The method is pretty simple. You got 3 steps. That's straightforward. You got coloration, neutralization, drying. That's it. That's all. So that's something that is interesting because actually you don't want to have a lot of steps to do. You want to have something that is short and neat. So to prepare the solution, there I've put you some kind of some information about the solution that we will use in the lab later on. So you use 1.5 gram of Oredo into methanol, and afterward you kind of do a solution with sodium hydroxide into water, and then you mix both together and filter the rest. So actually your Oredo is mixed with sodium hydroxide, methanol, and water. And the water is really important because actually the Oredo is not soluble in water. Afterward, you got your buffer solution. The buffer solution is really to bring back your pH to pH 7, and that's pretty important also. I won't go through all the explanation about this because actually you're going to see it in the lab, but well, you got it in the slide, so. The procedure, that is interesting. Actually, I put the procedure where you got the things to do, and finally I got some tips when you go in that point. So first, you just take your document and immerse it into the solution. You could use a tighter shaker plate, and you let it in the solution for 60 minutes to 90 minutes. That's it. You just don't have to look at it. Usually, the strong fingerprint goes out. If you got a good fingerprint, you're going to have good result after 5 to 10 minutes. So it's pretty quick. But usually, you better keep your exhibit into the solution in for about 60 minutes at least, just to make sure that you don't have any weak fingerprint that could be otherwhere onto the paper. Even if you leave the paper longer than the 90 minutes immersion that is recommended, you won't find anything better. So that's not the point. So actually, you don't go further than 90 minutes, but preferably no less time than 60 minutes. That's important. And the tighter shaker plate is optional. As long as you keep the paper immersed into the solution, that's enough. But the point is that if you got a lot of stuff going on in the lab in the same time, you want to have the shaker tighter plate that just goes like this, so your paper stays soaked all the time and could do something else, CA and Rhodamin 6G, some photograph at the same time. So it's all depends on what you want to do. Actually, I like this investment, but that's my point. So afterward, you just remove the document from the Oredo, drain a bit, and then you immerse it to the pH buffer. Just to bring your pH at the Oredo pH is around 8, so you bring it back to 7, which is neutral pH, just to make sure that your paper is neutralized and it's not become fragile and breakable. Actually, you got to get rid of all the sodium hydroxide also that could form on the surface, so that's important to use it. Finally, you could. That's kind of optional, but you could rinse the document into distilled water. Actually, I don't do it in the lab, but I know some people are doing it, and they got good result with it, so they just continue to do it, but it's not mandatory. And finally, you just let it dry. You could let it dry in open air, or you could use a oven. That's up to you. Actually, I prefer open air. That's my preference, but I know that some person just don't have the time to do it, so they go with the oven, and they got good result also. And that's really important. You take the photograph of the print always, just like the denidrin and all the other chemicals you're using, just to make sure that you don't lose any evidence that you're going to have. So that's the short version of the procedure without all the tips, but it's the same thing. So the principle, how it works. So the alredo is hydrophobic and lipophilic. So actually it's afraid of water, but it likes lipids. It will tend to refuge itself into the lipids, like those in the fingerprint residue. Okay, now I'm going to go into your high school stuff in chemistry. The way the alredo is working is that it works with the entropy of the solution. If you look at the thermodynamics law, the energy tends to disperse spontaneously if it's not constrained. For example, if you got a tire and you put air in it, actually all the air is going to be constrained. You got to have a pressure, and your tires goes up. So all the air is constrained into the place, so it looks like over here. So actually, if you puncture the tire, all the air is going to go out over here, and it's going to disperse all over the place. So the entropy is the measure of this dispersion. That's important. So usually in the nature, the energy tends to disperse, resulting into an increase into your entropy. And when you go into the increase of entropy, this way, you never go back this way. By itself, though. So the increase of entropy, the staining depends on the increase of the system of entropy. So the hydrophobic dye is dissolved into the region that contains water, and the stain is afraid of water. So they don't like to be mixed together. So that's the point. So when you put the solution in contact with fingerprint that contain lipids, then the dye don't want to stay with water, so they go into the lipids. So that's the way. That's not a chemical bounding or ionic stuff or covalent stuff. That's all about, he's afraid of water, he go out of water. That's the point. So natural tendency to increase the entropy again. Okay, so we're going to see how it works. So here you got kind of a latent fingerprint cross-section. And the little red dot is going to be the alredo particle, for example. So you got the friction ridge that is cut down the middle. You got the hydrophilic part of the lipids that are outside. Then the lipophilic part inside. And you got the paper sheet at the bottom of it. So the alredo is coming down into the solution, and it goes in, and it stains the ridge. So that's the way it works. It goes inside and not stay outside the ridge. So that's important. That's going to be more important even with the... Okay, great. Even with the physical developer explanation, you're going to see it later. And that's going to explain why both could work together also. So when should I use the alredo? The alredo should be used on dry and wet porous surface, because there have been a lot of experiments done with that kind of stuff. So you could integrate it into your sequence of dry porous surface after the denidrin, or after the indandion, and before the physical developer. So you could put it into your sequence you got already. So on dry porous surface, it could go like DFO denidrin alredo PD, or indandion alredo PD. It's all depends on what you do in your lab. So here's an example. Here at our office, we're doing DFO denidrin. So here you got a treatment with a DFO, for example. And afterwards, we treat it with alredo, so we got the result. So it works pretty well. Let's just jump over the denidrin, because actually you have all seen what's the result with that kind of stuff. An important thing there, that's really important. The ninhydrin in DFO and in Dandian shouldn't be used with pityriameter or heptane or all that kind of stuff as a carrier, because actually when you're mixing your stuff, you could use in the past that was CFC 113. Actually, it's illegal, so we couldn't use it anymore. So now you could use HFI 7100. You could use pityriameter. You could use heptane. You could use Vectrex. Vectrex, did it exist again? No, I don't think so. Well, anyway, so the pityriameter and heptane, the big problem that we got is that those kind of chemicals, we use it in biology to extract lipids. So that's a big point. So if you extract all the lipids of your paperwork or the paper you want to work on, your evidence, you won't have any lipids left for the alredo. So you're gonna be stuck. You won't have any result with it. Because actually we have some trials with the guy of the FBI, and he called me and said, "Well, your stuff's not working." Why it's not working? Actually, everybody called me and said, "Well, it's working. I got good result and all that stuff." And finally, we find out that they were using pityriameter as a carrier, so they got big problem. I know that the other carrier is more expensive, but at the end of the day, you got better results. So it all depends on what you're looking for, just like Brian said. So actually, as I said, later on, we're using a CFC 113 that is prohibited right now. So we suggest you HFE 7100. That works pretty well. And then I invite you to take a look at the Radstar research in 2000 and maybe use it to present it to your boss if you don't have already that chemicals. Actually, it's a good research, so it gives you a good result for your management. So again, when did I use the alredo? For wet porous surface, I'm going to use it just before the physical developer. So the sequence is going to be alredo physical developer then. So some people were asking me some question about, well, if I use your alredo first and the physical developer afterward, will I have enough or not enough contrast to get some results? So if you could just shut down the light a bit. Thank you. So you see, you got some problem with contrast, but actually in today's technology, it's not really a problem, because actually if you just get rid of the red layer of the pictures, you're going to have good result even, so it's not really a problem. But at the beginning, if you just look at it right like this, you could see a problem, but at the end of the day, it just don't matter at all. We got an Australian validation, just as I talked at the beginning of the presentation, that were from the University of Technology in Sydney. They look at the alredo formulation, and finally they found out that all the concentration law, that stuff, was the best to find fingerprint. That was great. And actually they find out that using alredo and PD in sequence give best result than using PD alone or alredo alone. So that was great to know also. And finally, they find out that after 30 days, just the first 30 days of a case, actually, the alredo is always superior to PD. But after 30 days, the PD start to become better than the alredo. So that was important also. That's important because actually, with that finding, they still continue to say that we could use both together. And the reason why is that even if the PD become better than alredo after 30 days, it doesn't mean alredo is not going to find anything. And that's important. And I got a cold case to show you about this. We got a cold case of 21 years of age. That was a murder in the region of Montreal. At that time, the paper was just not treated at all. So I don't know why, but well, after 21 years, they just bring it to the lab, and I take a look at it, and finally, well, I'm going to do DFO in the ninhydrin. That's the first thing to do in this. So I do the DFO in the ninhydrin without any result at all. So I said, well, that's the time to use the alredo then. So I give it a try with the alredo, and I find 2 fingerprints. That was not there with the amino acid, but was there with the lipids. And it was 21 years later. So it doesn't mean that your alredo won't work after 30 days. It just means that both of them together is going to give you a better result. So in conclusion, the alredo is a sample technique for wet porous surface and dry porous surface. Consistently superior to physical developer for case less than 30 days old. Can be added into your treatment sequence after ninhydrin or the endandion, and before the physical developer on dry porous surface, and before the physical developer only on the wet porous surface. And still working after 30 days. That's important to remember. So I don't know if you got some questions. Yep.
You mentioned that it works well with the HFE 7100, but how does it work with acetone-based or alcohol-based ninhydrin?
Acetone, I don't think you're going to have any problem with this since we're using methanol into the solution. So I don't think it's going to have big problem with this. But I haven't tried it. So if you got some result with it, that would be interesting to share. But I don't have any result with it. But that could be interesting to see. But I don't see any problem with this because since it's still alcohol and the alcohol is not really used to extract lipids, I don't see any problem with this.
When you did work,
Yeah.
I'm sorry, okay. When you did work, did you look at different paper types? I know we did just some preliminary studies with Orvedo, and some of the types of paper had that, it looked like the fingerprint, but there was no ridge detail at all, it just kind of blurred out. Is it, do you know, is it pore size? What affects that?
Yeah, actually, the big point on this is that the different type of paper got different size of pore on it. And actually, if you got the printer paper, the one we're using with all the stuff at the office, usually that's all even small micro pore. So actually, for Orvedo, it's pretty good. But after a while, when you go with less quality paper, let's say a journal paper, for example, the lipids gonna tend to goes into the paper and just extend, and then you lost the ridge. But you know you got a red blob on your paper. So if you do the Orvedo first, for example, and you don't have any ridge detail, but you got a red spot, you know that if you do the physical developer, you're going to find the fingerprint there. So that's great, because actually you don't have to flip over and flip over and flip over your paper to see if you got something on it. So actually it gives you an insight where to look at the end of the day. So it's not lost. So we never know, actually, and even sometime after a week, the lipids have migrated into the paper, and sometime after 21 years, you still got the lipids on the surface. So it's all depend of the quality of the paper. But usually when I go with a paper just like brown paper for fish and all that stuff, I used to do the Orvedo on it even, just to have a place to look at. So the physical developer is easier for me to do, and I'm losing less time on it actually because I'm looking only to one spot. So that's easier that way. Yep.
In the test run, that chart that you showed where it lost effectiveness after 30 days,
Yep.
was that loss of effectiveness, was the print not showing up?
No,
that
actually
what it
that was
was,
the
or-
ridge detail. The ridge detail that you lost at the end of the day. Because the lipids goes in your paper,
Mm-hmm.
so the point is that you're losing the sharpness of your ridge.
Okay.
And that tests were made on wet porous surface, not on dry porous surface, which is different. That's important.
Okay.
When you aged, did you age in environmental chamber? What was the temperature you?
Actually, I didn't did it myself, but when they do it, I think they keep it into the lab, which is the temperature and the humidity were kind of stable.
So it was like a lab thing,
Yeah.
it wasn't-
Yep.
Have you ever used this process on paper money and any results better than the other
On
process?
paper money, not really. Usually when we got that kind of paper, actually with the Canadian money, we're still using the DFO or the endandion directly without using anything else. Because actually with all the color that they got and all the lines that we got on our money, that kind of difficult. I know that we did some American dollar and we find good fingerprint with ninhydrin that we couldn't find on Canadian dollar at all because it's not the same type of paper. So I haven't tested the Orvedo on dollar at all yet, but that could be interesting to see. Actually, because the paper for the money is probably more stable, and with micropores, you're gonna have good result at the end of the day. Other question? Yeah.
Shelf life
Yep.
for unmixed and mixed.
Okay. Unmixed chemicals. Well, you could keep it pretty long because actually the Alredo is kind of a powder. So as long as you don't have any humidity in your powder, you don't have any problem with it. When the chemical is mixed with the sodium hydroxide and the Alredo and all that stuff, actually in our lab we're keeping it for a year without any problem. The big problem you're going to have is that your methanol is going to evaporate if your bottle is not closed tightly. So if you lose your methanol, then you're going to have kind of a crystals of sodium hydroxide that are going to form into the bottle, and maybe it's going to form into your tray. So you're going to have some problem with this. So it's not actually, if you see that your Alredo is changing from kind of a Bordeaux wine from a color that is more orange type, that's not good. You better change it.
Now that was just for the. Oh, what about for the buffer solution?
The buffer solution could be used for a year easily. But you could also buy it all done. There's buffer on the commercial market to bring back something to pH 7 that's already done, and you don't have to mix it. That's really up to you. But
So you don't have to do that. Use that one.
it's more costly.
Okay.
The big point is to bring back the pH to 7. Yeah?
I've been getting a lot of receipts on the thermal paper, and then anhydrous turns it completely black. Are
Yeah.
any of these processes better for that?
For the thermal paper, first for your ninhydrin, give it a try and soak into your ninhydrin for a long time. Usually the black stuff is going to go out and going to have good result first. Afterward, I made a test between thermal paper or with the Alredo and PD, and I got much more result with the Alredo than I got with the PD. But at the end of the day, the thermal paper is not really good either for Alredo and PD after a week. So that's pretty that's pretty short. So if you got something that is new, you could use your PD. You go with ninhydrin and or no, not the DFO though. You could do with your Invalidation, for example, and then go with your Alredo and physical developer if you wish. But at the end of the day, if it's more than 1 week, that's not a good idea. You also get some stuff like muriatic acid and all that stuff, but it don't works well after a week either. So I think the better way to do it is in the ninhydrin. And when it's wet, you don't have any choice, so you try the Alredo and you're going to see. The big problem with the thermal paper with the physical developer is just that because the silver is going to react with the surface of the paper, so it's going to become all black. So the results are not sharp enough to find something. Other questions? Good.